Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on November 4th, 2025, about 3 days ago. This paper introduces TabTune, a unified library that standardizes the full workflow for tabular foundation models, and finds that these models beat classical ensembles by about 2 to 4 percentage points, while parameter-efficient fine-tuning with LoRA retains about 95% of full fine-tuning accuracy, with roughly 60 to 80% lower memory. The paper is titled TabTune, a unified library for inference and fine-tuning tabular foundation models. And as we will see, the implications for reliable evaluation and practical deployment are quite significant. Also, the authors shared a GitHub repo. You'll find a full Python library with the TabTune package, examples, and docs, plus tests. It includes a scikit-learn-style API for fit, predict, evaluate, and save or load. It supports multiple tabular foundation models, fine-tuning strategies including PEFT, checkpoint management, and a leaderboard for benchmarking. Alright, the repository details were clear, and Figure 1 shows how the system turns raw tables into reliable model outputs. The diagram lays out 4 pieces that work in sequence: a data preprocessor, a tabular pipeline, a tuning manager, and an evaluation suite. The orchestration engine coordinates these pieces so users call one interface, while the library handles model-specific quirks. Evaluation explicitly tracks accuracy, calibration, and fairness, which means probability estimates match outcomes and group biases are measured. Alright, Figure 2 shows how the system turns many moving parts into one consistent pipeline. The central orchestration layer routes data and choices, so users call one interface, while the library handles model specifics. On the bottom band, the data processor, model hub, and tuning manager run preprocessing, select a tabular foundation model, then apply zero-shot, fine-tuning, or parameter-efficient tuning with LoRA. To the right, evaluation and deployment complete the workflow. Okay, the pipeline view was broad. Table 1 lists the supported tabular foundation models and the learning style each one follows. In context, learning means the model adapts from a small support set provided with the task, so it can generalize without full retraining. Other paradigms include scalable and context learning for larger tables, denoising transformer that learns by reconstructing perturbed data, and prior-fitted network that approximates Bayesian reasoning from synthetic priors. The key features span multi-scale sparse attention with perceiver-like memory, biaxial and column then row attention, row and column attention with synthetic priors, modality-aware semantic embeddings, diffusion-based pre-training, and Bayesian-style inference. Alright, Table 3 reports the overall leaderboard, so it compares models and adaptation strategies head-to-head across 3 benchmark suites. The key message is that pre-trained tabular models lead, which matters because they generalize without heavy task-specific training. In the zero-shot block, OrionMSP edged out strong accuracy while TabPFN stayed close. Supervised fine-tuning lifted TabPFN the most. At the bottom, the PEFT supervised section shows lightweight adapters retaining high scores with far lower cost. Alright, 2 takeaways stand out. A single, consistent pipeline makes tabular foundation models practical, with built-in checks for accuracy, calibration, and fairness. And lightweight adapters via LoRA keep roughly 95% of full fine-tuning performance while slashing memory. The broader implication is dependable, reproducible deployment across sensitive domains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.